Anisul, welcome to AE classes. Anisul, can you tell me whether I'm audible or not? I'm audible or not? You can just type it in the chat box. Anisul, can you tell me I am audible to you or not? Can you see me? Can you see the screen? Good evening, Jongshar. Can you hear me? Am I audible? We're already running behind the schedule, guys. Just type it in the chat section whether I'm audible to you all or not, please, so that we can proceed with our class. Okay. Okay, thank you. Thank you for the response. So while we wait for others to join, let's start with today's discussion. First of all, welcome to AE classes. And today is our first session, I think. Uh, previously I've already completed the introductory part where we have discussed the different syllabus included in the gate exam of agricultural engineering. So today this is just one part of today we will be completing some questions. We will be solving some questions that has come from the SWCE and IDE section in the GATE 2023 exam. Okay, so I hope that you all have prepared with your pen and notebook so that you can note down whatever is being uh, shown in the screen. Okay, so before we start, I would like to ask you whether let me just okay, so I will write something in the PPT. Okay, I'll write something in the class board and please let me know whether you can see the writings or not. All right. Can you see the hello written in the screen, in my screen? All right then. So discussing some of the questions and I have left out more questions for the next class. Okay. So let's see what things can be covered within this 1 hour period because we're already 15 minutes behind, right? So at any point of time, if you have any questions, any doubts, please feel free to ask me. Just type in the chat sections whenever you have any questions, or if you're unable to reach at that moment, you can always come forward and meet me in the person in the class itself. All right, so let's start with our first question from see in this class I have selected some few questions, and MCQs, I mean the theory related questions will be done in the next part. Okay, so for today's part, the first question is question number 21 from GATE 2023. And this question says, a sprinkler irrigation system has been designed for a crop with a water application rate. Okay, so here the application rate is given. So what is application rate? The depth of water that you give per unit time, isn't it? So it can be mm per second also, per minute also. Okay, and you see the sprinkler discharge is given here as the 1.3 liter per second. Okay, so we have the application rate, let's say it's equal to RA, application rate is equal to 1.17 centimeter per hour, and the discharge rate, that is sprinkler discharge, Q is given by 1.3 liter per second. Okay, now the coefficient of discharge you see is CD. So let's take CD as coefficient of discharge is equal to 0.9, and coefficient of uniformity, that is CU, is given as 0.8. Okay, so you see the sprinkler spacing along the lateral. Okay, so now in a sprinkler irrigation system, in the design of a sprinkler irrigation system, it's very important to identify the distance, lateral spacing. Okay, lateral spacing and the sprinkler spacing along the lateral. So this is your main line. Then if this is the laterals, okay, if these are the laterals and the sprinklers are provided in this laterals. Okay, so these are your sprinklers. So you see this is the sprinkler spacing, isn't it? This is the sprinkler spacing, and this is the lateral spacing. Okay, so you have to find this lateral spacing in meter. Now in the design of a sprinkler irrigation system, there is a particular formula that you might be already familiar with. Okay, so this is given by discharge equal to SS into SL into RA by 360. Okay, this is the formula that we use to calculate the discharge that comes out of a sprinkler nozzle. All right, so SS here represents the sprinkler spacing. Okay, SS represents the sprinkler spacing, remember this. Okay, and SL represents the lateral spacing. So if you put this value, this is a very simple equation, you just have to remember the formula. Okay, this is a very simple easy problem, and I think if you remember this formula, you will be able to solve it very easily, because this is a direct formula question, right? So just put the values and try to solve the problem. Okay, so so Q is given as and yeah, one more thing, you always have to remember the units. Okay, so Q is given as 1.3, right? So okay, let's just convert this equation in terms of SL. Okay, SL will be equal to what? Q into 360 divided by SS into RA, right? So Q is how much? 1.3. Okay, 1.3 into 360, and SS is how much here? Just 1 second. SS is how much? 20. Okay, one more thing here. You have to SL, this one into CD into CU. Okay, so if I put this, convert this formula, then it will be CD into coefficient of discharge and uniformity coefficient. So this will become 0.9 into 0.8. Okay, so try solving it. All of you, please solve it and tell me in the chat section what result you're getting. Solve it quickly and tell me what is the result that you're getting. So once you solve this problem, I think you will be getting the result is 20, isn't it? 20 meter. Okay, so this is the answer given in option D of the question. Okay, wasn't this easy? I think this was a very easy problem. Okay, so I think this is clear to you all. Now we will proceed to the next question. And this is question number 23. Okay, and this is a question particularly related to surveying and leveling. I think you all have studied surveying leveling in your second year, right? So I think if you recall the definition of WCB, so let's have a look at the question first. Okay, so the question states that if the departure is 70 meter and the latitude is given as 130 minus 130 meter, then what is the whole circle bearing in degrees. Okay, so do you remember the definition of whole circle bearing? So whole circle bearing is the magnetic WCB. Okay, whole circle bearing is the magnetic bearing of a line measured clockwise. Okay, you have to remember this is measured clockwise from North Pole. Okay, from North Pole towards the line. All right, then I'll just show you a picture, figure of this. So the value generally ranges from 0 degree to 360 degree only. Okay, and it is measured using a prismatic compass. Okay, so you see for this particular equation, the figure will be like this. Okay, so suppose that so as I say, line is measured clockwise, isn't it? From what? From where? From North Pole. Okay, from the North Pole. So say, let's take this as the here it represents the North Pole. So now what is the question here? What is the whole circle bearing? Okay, if departure is 70 meter and latitude is minus 130 meter. Okay, so departure it will be like this. Okay, so you see, sorry, let me change the color. This is the whole circle bearing. This is given by, let this be theta. Okay, and this here, let this represent the, let this be alpha. Okay, so you see here, this distance here represents the departure. Okay, this direction, departure is given in this direction, and the latitude is given as this direction. Okay, so latitude is how much? Minus 130, right? So basically this is the value of x and this is the value of y only. Okay, if you try to look it as a plane coordinate geometry, then departure is how much? 70 degree. Okay, this is equal to, d is equal to 70 meter, and the latitude is given as minus 130 meter. All right, so now what is the formula for solving this? This is also a direct direct formula problem. Okay, now if you remember, whole circle bearing formula is this. First we need to solve this tan alpha. Okay, I mean, if we can find out what is alpha, then you can easily find out the value of theta by subtracting alpha from 180 degree, right? This total angle is how much? 180 degrees. So if you can find out alpha, you can easily find out the value of the whole circle bearing. Okay, so the formula for finding this tan alpha is given as tan alpha equal to d by L. Very simple formula. Okay, departure by latitude. So here we do not take the negative value. Okay, negative value is just simply for or even if you take also, it won't matter much. All right, so d is equal to how much? 70 by 130. So alpha will be equal to how much? Tan inverse. Tan inverse, okay, this value is equal to 0.538. Okay, so the tan inverse, you see, if for finding out such kind of problems where tan inverse or e to the power something, you need to be very much familiar with the virtual calculator. So it's my suggestion that all of you install an application of means using a virtual calculator and try to solve problems, so that it will enhance your solving ability, and you will be able to save more time in the final exam. Okay, final gate exam, I mean. So alpha is equal to tan inverse of 0.538. This is equivalent to how much? 28.28. Now you can find out the value of WCB. Okay, WCB will be equal to theta. This is equal to how much? This will be equal to 180 minus 28.28. Okay, How much is this? The value of this is 151.72 degree. Okay, equivalent to 152 degrees. So this is the value given in which option? Option C. Okay, so this is also a direct. Okay, good evening, Manish. Manish has joined just now, I think. So I hope that this problem was clear to you all. So let me tell you again that whenever you have any problem, please let me know. Whenever you're having any kind of doubt, you just have to write it in the chat box, or I think there is a provision for you to even unmute yourself, and I mean, you can ask permission for unmuting yourself. Then I saw that in the earlier class. Okay, so since we are all this is a new platform for us also, we are also adjusting to the system settings here, and sometimes we may not be like well versed in this. Okay, so it may थोड़ा थोड़ा तो प्रॉब्लम होने के चांसेस है ही, ठीक है. So kindly bear with us also. We are learning, but we are all learning. All right. So this was the second problem that we have solved. And those who have joined now, let's see if we have enough time. Then we will come back to those previous numerical that we have already completed. Okay. So let's move to the other numerical now. This numerical you see here, question number 32 from gate 23. It's a big problem. Okay, it's a big numerical, I would say, because whenever you come across this designing, but if you know the formulas, now if you have already by hearted learned by heart the formulas, then it's a very easy problem. It's not very complex. Okay, so but you need to have a clear concept of few things like slope is a very important factor whenever it comes to designing of waterways. Okay, so if you're able to solve this grass waterways, okay, say trapezoidal shape है ना. Trapezoidal shape सिर्फ grass water way में भी नहीं होता है, isn't it? ये grass water way हो गया, it will be like this, isn't it? Water will be flowing through this. Whereas in case of questions also comes in the form of designing of graded bun. Graded bun, contour bun. Graded bun क्या होता है? Does anybody know? Graded bun, contour bun. Okay, so these are all soil erosion conservation practices. Okay, these are performed in areas with slightly sloped areas. Okay, so in the graded bun you see mostly in the graded bun grades, okay, or grades or gradients are provided for the discharge of water. Okay, I mean basically the run of water that will take place because of excess rainfall, right? So in the graded bund also, whether it be contour bund or graded bund, generally the shape of the bund is always given in trapezoidal shape. So if you can if you know the how to find out the dimensions of this one, then you can easily solve any kind of problem related to this trapezoidal shape. Okay, so let's make a trapezoidal waterway as per the given question. Just a second. So you see here, let's first make the trapezoidal grass waterway. Okay, so let's take this as the top with sides, and this is the bottom width. And you know that the trapezoidal is divided into three sections, isn't it? One is the rectangle or the square part, which lies in the middle of the section, and two triangular parts. Okay, and now the question says that the side slope, okay, side slope is given as how much? 1:1. Now the side slope is always you remember, whether it be a weir or a bund or terraces, whenever you hear this term side slope, you should always remember that this 1:1 is equal to, it gives the ratio of the horizontal is to vertical. Okay, horizontal is to vertical. Whenever we write a slope, we generally represent the slope by rise by run, isn't it? Whereas it's the opposite in this case. Okay, horizontal is what? This, isn't it? Basically this is the run, isn't it? And vertical is what? The rise. Okay, so it's the opposite in this case, so you always have to make sure. Okay, don't get confused with the land slope that is given, like here in this case the bad slope here is given as 1%. Okay, the bad slope here is 1%. It means that the rise is 1 in run of 100, isn't it? So this is the rise. Okay, rise by run, this is the slope of the channel, whereas the side slope is always given by h is to v, that is the opposite of this slope, that is run by rise. Okay, always remember this. All right, so the side slope is given as h is to v. Okay, h is to v is how much? 1:1. Or we can since this is, some of you may be familiar with the problems related to this, and for some of you it might be new, isn't it? So I'll just try to express the formulas in the generalized way also. All right, so h is to v, and this can also be written as, generally it's also written as 1:n. Okay, in some books you will find 1:z also. 1:z also you'll find. Okay, so anyway, side slope here represents this slope, the slope of this side. Okay, side of the channel. So this is given as 1:1. Here what is n? N is equal to how much? 1 only, isn't it? So n is equal to 1 here in this case. Okay, so n can be anything for another type of design for slope. It can vary for different designs as well. Okay, so let's take the depth as d in this case, and you see this is the top, isn't it? Top width of the trapezoidal channel. Okay, or t. So you see here, now you see this, for you need to clear this concept first. Okay, for one rise, isn't it? One rise will be equal to how much run? One run, isn't it? As per the ratio given for the side slope. Okay, for one rise the run is how much? 1, isn't it? So for d rise, so for this depth, for d rise it will be how much? Suppose, okay, more in a more generalized form, so that in any other question, if the side slope is given in a different way, then you will be having the concept. So I'll just write this as n run. Okay, for one rise let the run be n, then for d rise the run will be how much? Nd. Okay, for d rise the run will be nd, isn't it? So for this d rise the run will be how much? Nd. Okay, my figure is not to scale, so it looks very small here. Okay, so similarly same case for here also, because the side slope will remain same, isn't it? This is also a depth. Okay, and this is how much? B, isn't it? This is the parallels, so it will be having the same dimension, isn't it? So I hope that you have understood this concept. Okay, and now you see, okay, moreover, what are the things that is given? Side slope part is over, and you see the discharge here. Q is given as 1 meter cube per second. Okay, and the slope of the channel is given as 1%. This is equal to 1/100. Okay, so remember this is given as rise by run. And Manning's coefficient is n. Let's not take n because we are already taking the side slope as n. So let's take the Manning's coefficient as z. Okay, so z is equal to how much? 0.04. Now remember, whenever we talk about open channel flow, whenever you solve any problem related to open channel flow, you will always find the velocity calculation using मैनिंग्स फॉर्मूला, दिस इज वेरी इंपॉर्टेंट, इसको रट्टा मार लो, आप लोग जो करने कर लो, लेकिन इसको याद करके रखो। मैनिंग्स फॉर्मूला, मैनिंग्स फॉर्मूला आएंगे बाद में, we will discuss the formula of this the velocity, open channel flow. Okay, open channel flow velocity is always calculated using this Manning's formula, whereas for pipe flow or conduit flow, it will depend on the different aspects of the pipe or the conduit shape, size, the type of the conduit in which the flow is taking place. Okay, so whereas for most of the questions, you see, most of the problems, you will find that whether it be designing of grass waterway or designing of the graded bed or contour bed, if you're having this designing, then you will always come across this Manning's formula only. Okay, so and anyways, so let's continue with the discussion. And okay, so you see, now what are the things that you have to find out? You have to find out the depth. Okay, D here. You have to find out the D. Okay, so now it's also saying that the trapezoidal is having, okay, the trapezoidal grass waterway is having the best hydraulic section. Ekdam thumbs up. Best hydraulic trapezoidal grassed waterway. So for a grassed waterway, you see, for best, always remember, okay, this is another star point that you have to remember. For best hydraulic design, for best hydraulic design, B, okay, यानी कि B क्या है यहाँ पे? Base, okay, this is the base width, okay, B is the base width. For hydraulic design, for the best hydraulic design of a trapezoidal section, B is always equal to 2d 10 theta by 2. Okay, now you must be imagining कहाँ से आएगा ये theta? That is the beauty of this structure, of this figure. Theta कहाँ से आएगा? Theta का formula क्या होता है? Perpendicular by base, isn't it? So perpendicular by base क्या है यहाँ पे? Let's take this as theta. Then इसका formula क्या होगा? Tan theta. Theta will be how much? Okay, so okay, let me erase this, the bottom part first. So tan थीटा क्या होता है, क्या होगा यहाँ पे? tan थीटा इक्वल टू परपेंडिकुलर बाय बेस. परपेंडिकुलर क्या है यहाँ पे? 1/1. और if you say why not d, why don't you take d? Let's say, okay, take d. Perpendicular is how much? D. And what is the base here? Base is this, isn't it? nd. N is what here in this case? It's 1. So it's also d. So d by d cancelled. It's equal to 1. This is equal to 1. So tan theta is equal to 1. Then what is theta? Theta will be tan inverse, isn't it? Tan inverse of 1. This is equal to how much? 45 degree. Okay, so you have got the value of 45 degree as the value of theta. Okay, so obviously putting this value, I'm going to change the slide now. I'll open a new work area. So I said for economical section design, okay, this is B is equal to 2d tan theta by 2. Okay, so if we put the value of theta as 45 degree, then B will be how much? 2d tan 45 by 2, correct? So the value of D, after solving it, you will find it as 0.83 D. Okay, you can always try it by yourself and you will find that the value of B in this case is 0.83 D. Okay, now you see, after this you have to find out the cross-sectional area. So this is, like I said in the beginning of the this numerical problem, this is quite a lengthy process. So moreover, it's your, I think most of you are solving this problem for a first time, okay, and others might be already familiar with it, but you see, that's why it might take a little bit time to get accustomed to it, but then with practice everything will become easy. Okay, and you don't need to keep on like finding out the deriving the formula. If when once you are already familiar with this, you can simply just write down the direct formula and solve it also. All right, so cross sectional area here is equal to you see, just imagine that if you don't remember the formula, then for a trapezoidal channel, the cross sectional area is always the sum of the three sections that you see in the screen. Two triangles plus one rectangular square. Okay, so cross sectional area will be how much? Okay, well, moreover, the formula for the finding the area of trapezoidal is how much? What is the formula? I mean, it's equal to half into height, isn't it? Height in this case is d. Okay, height in this case is how much? D. Okay, and uh, this is base, right? This is nd and nd. So d into top width plus bottom width. Okay, bottom width is given by b, and the top width is equal to 2nd plus b, isn't it? So we have half into d 2b plus 2nd. So cancelling all the 2's from the top and bottom, what are we left with? BD plus ND squared. This is the cross-sectional area. So if you put the value of B as 0.3D, okay, if you put the value, and we know the value of N is equal to 1, isn't it? And if you put this value also, what do you get? This will give you 0.83 D square plus D square. Okay. So this is equal to how much? 1.83 D square. So up to this much is clear to you all. Kindly response in the chat section. Is it clear to you all till this much? Those who are present, kindly give your response. Is it clear up to this much? Is it clear, everyone? Okay, okay. Okay, thank you, Anisul, for your response. Okay, so now let's proceed to the next part of the problem. So I'll tell you why I'm solving so many things for this one problem. Okay, because the ultimate formula requires all these data. Okay, so all right. So now once you have solved the cross sectional area, the next parameter that you need to solve is the wetted perimeter. Okay, wetted perimeter. Now what is this wetted perimeter? You see, in a trapezoidal section, this part will be in contact with the water, isn't it? Here we do not construct any kind of thing. This is open. Okay, open to the atmosphere. Water will flow above the will flow in this channel, isn't it? So wetted perimeter is the part of the structure which comes in contact with the water. Okay, so basically this plus this is the wetted perimeter. Okay, so wetted perimeter, you see. Now how we do derive this formula of the wetted perimeter again? Just think of the trapezoidal section again. So this plus this, isn't it? So wetted perimeter will be equal to, now this slanting area, slanting line will be equal to, if you take Pythagoras theorem, then say that this one, okay, 1 will be equal to how much? Root over, what was this? D, isn't it? D square plus n square d square, isn't it? So this is equal to how much? D square 1 plus n square. Okay, now we have two similar sides, isn't it? So ultimately wetted perimeter will be equal to, this number 2 is equal to how much? B only, base only, isn't it? Base plus 2 times of this, isn't it? 2 times of d square root over 1 plus n square. Okay, this is the formula for calculating any kind of, I mean, wetted perimeter of any value. If in the question b is given or d is given or n is given, this is how you calculate. This is the formula for calculating the wetted perimeter of trapezoidal section. Okay, so So now you see wetted perimeter is derived as b plus 2d square into root over 1 plus n square. Okay, now if you put the value of again इसके जगह पे substitute बिठाओ. Okay, so when you put the value of b and n, then what is the result here? It will give you 0.83d. Okay, b का value क्या था, हमने solve किया था, right? 0.83d plus 2d root 2. Okay, n is equal to 1 again. Then this is equal to 0.83d plus, again root 2 का value आपको you have to remember 2.82d. Okay, this is equal to how much? 3.65d. Okay, so we have got our area, we have got our wetted perimeter. Now the next thing comes again, one more very important term, that is known as the hydraulic radius. Hydraulic radius. Whenever designing any kind of grass waterway, be it rectangular channel, be it be it circular or be it parabolic, you always have to remember this 4 or 5 parameters: area, wetted perimeter, and the hydraulic radius, and obviously the Manning's formula. Okay, always remember this. So hydraulic radius is given by R is equal to A by P. Area of the channel, I mean area of the cross sectional area, this one, structure, and cross-sectional area divided by the wetted perimeter. Okay, so area we have already derived at as how much? 1.83d square, isn't it? 1.83d square. And what is the wetted perimeter? 3.65d. So this is equal to how much? 0.5d. Okay, 0.5d. Now the most common, the most easiest formula to solve this charge, this is given by what? Q equal to A into V. Area into what? Velocity. So this velocity here is Manning's velocity. Okay, Manning's velocity. So now Manning's velocity is given by, now comes the ultimate formula. Manning's velocity is given by V is equal to 1 by n r to the power 2 by 3 into s to the power 1 by 2 or root s. Okay, so this formula kindly always remember. ठीक है, so अभी area हमें क्या मिला है? So just simply put the formula now. Area क्या आ रहा है? 1.83d square into V is how much? 1 by n, sorry, z होगा यहाँ पे, ठीक है, z 1 by z 0.04 into what? R is how much? R is how much? Okay, just 1 second. Huh. R is how much? 0.5d to the power 2 by 3. And S is how much now in the question? S was given as how much? 1%. This is equal to 1 by 100. Okay. So 1 by 100, 1 by 2, power to the power 1 by 2. So Q is also already given in the question as 1, isn't it? 1 meter cube per second. So solving this, okay, solving this, you will find once you solve this, simplify it, you will find that the d is raised to the power 8 by 3 is equal to 1 by 2.88. You should get this value. Okay, so once you remove this power, then d's value will be equal to what? 1 by 2.88 to the power to the power what? 3 by 8, isn't it? So this is equal to d's value is equal to 0.67 meter. Okay, so this is your final answer. Okay, so this part you try to do it by yourself, try to simplify it by yourself. Okay, d's value should be equal to 0.67 meter. Okay, so okay, I think my face is coming in front of the d's value. It's 0.67. okay, I'll just write it here. D is equal to 0.67 meter. This is the ultimate answer. ठीक है, clear? Is this problem clear? Please tell me. I want to know from you all. Students, is this clear to you? बच्चों रेस्पॉन्स देना बहुत जरूरी है, वरना इट सीम्स लाइक आई एम टॉकिंग टू माई सेल्फ ओनली. काइंडली रेस्पॉन्स, गिव योर रेस्पॉन्स, से समथिंग प्लीज. Yes, 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 clear. Okay, thank you. All right then. So let's, we don't have much time left also. Still, let's see what can we do. Infiltration capacity of a basin. I think have if you have already done infiltration, then it will be easy for you because uh, you see, okay. Still, I will do it. Okay. सीखना तो है ही बाद में भी, isn't it? Moreover, today's session is all about solving this paper. So all right, so let's have a look at this question. Infiltration capacity of basin is given by this Horton's equation of I equal to 2 plus e to the power minus 3t. Okay, I equal to 2 plus e to the power minus 3t, where I is the intensity, I mean infiltration, this one capacity in centimeter per hour, and duration t is in hours. If the duration of the storm event is 2 hours, so you see t is here is given as 2 hours total, I mean the total duration. Okay, total duration is given as 2 hours. Now what do we have to find? What is the depth of infiltration? I. Okay, I in the last 1 hour of the storm. Okay, so how do we approach this? Now you have to break this. You see, time is how much? 2 hours. Total duration is how much? 2 hours. So zero. Okay, at first it started from zero, then it proceeded towards completed the first hour. Okay, first hour, 1 hour, then again 2 hour, isn't it? So we can break this whole duration in terms of hours into two different groups. So basically the question is asking you to find out the infiltration at this period. Okay, from the mid 1 hour to the last hour. Okay, so you see here we have to use the integration. Okay, calculus सबको याद है, I guess engineering students लोग तो आना चाहिए, राइट? थोड़ा बहुत कैलकुलस, derivations and integrations. All right, so you see duration. Okay, let me just write it down for you. Duration क्या है? Duration is 0 to 1 hour to 2 hour. All right, and so I is the okay, just take it capital I. This is equal to how much? I is the infiltration this one capacity or the depth of infiltration. Say depth of infiltration I dt. Okay, I equal to, okay, just wait. ये हो गया जो इक्वेशन दिया है यहाँ पे, हॉटन्स इक्वेशन इज रिप्रेजेंटेड गिविंग द इन्फिल्ट्रेशन कैपेसिटी. ओके, and let the infiltration depth be given by small I. Okay, ये नहीं है, कुछ भी नहीं है, इरेज नहीं हो रहा है मेरा स्क्रीन से, so kindly ignore the bar. Okay, so I, let this be the depth of infiltration, and this is equal to I integration of I dt. Okay, so this is equal to, like I said, from what is the condition here, 1 hour to 2 hour, isn't it? So simply very simple, 1 to 2 ले जाओ इसको, 1 hour to 2. So just put the value of I here. I का equation क्या दिया है यहाँ पे? 2 plus e minus 3t into dt. Okay, so this one will be how much? Integration, if you do it, say 2 dt will be equal to 2t only, isn't it? So if I break this, it will be 2t to the power 2. I'm not power, I mean the boundaries will be 2 and 1 plus e to the power minus 3t, 2 and 1. Okay, solve this. This will be, ये क्या होगा? 2 into 2 minus 2 into 1. Similarly, this will be e into minus 6, isn't it? Okay, let me write it here. Okay, 2 into 2 is 4. 4 minus 2 is how much? 2, isn't it? 2 plus e to the power minus 3 into 2 minus e to the power minus 3 into 1. Okay, this will be equal to 2. If you solve it, if you find the value of this one, then it will be equal to 2 minus 0.047. All right. So this is equal to 1.95 only, almost similar to 2 centimeter. Okay, this is the 2 centimeter is given in the option C of the problem. Okay. So yeah, it might be, this might be a bit new topic for you all, but still then with practice, like I said earlier, everything will become easy for you. Okay, so this is one of the questions that was asked in the gate 23 paper. And okay, let's do a small numerical. Okay, small numerical which will, so that we can cover it in a short period of time. Okay, so you can see in the screen, the question is given: discharge from a centrifugal pump operating at RPM of 1000 with a total head of 30 meter is very. Now you see, this is a very easy question. Okay, so again you have to remember the relation between the head, discharge, and RPM. Okay, head, discharge, and RPM. So for water, for a pump, okay, discharge from a centrifugal pump, the relation is given as H1 by H2 equal to N1 by N2 to the power 2. Very important question. I mean, the very important formula. So you see, there is a first one. The first pump, it is operating at 1000 RPM, and the head is 30, and discharge is 300 liter per minute. Right? Then the pump efficiency is how much? 65%. Okay. So now, if the speed is increased, okay, once the speed is increased, what is the power required to operate the pump? Okay, and the after increasing the speed, what is the new speed here? 1200 RPM. Okay. So you see, let's what are the things which are given? Given N1, that is the first RPM speed. First speed is given as 1000 RPM. Then H1 head is how much? 30 meter. Then Q1 is how much? 300 liter per minute. ये देखो, लीटर पर मिनट आ गया. कन्वर्जन करना होगा इसका बाद में. Okay, we'll convert it directly in the formula. And efficiency is given as 65%. And what else? N2 is this much. What is the power in kilowatt? Okay, power in kilowatt. Now, using this formula, just put these values in this formula. H1 is how much? 30 by H2 equal to 1000 by 1200 to the power 2. So if you solve H2, it will be equal to how much? 43.54 meter. Okay. So this is given. Now one more factor is given here. One more parameter here is Q, isn't it? Now how to relate this Q to the rest of the things like the head and the speed? So there is a particular formula for these as well, that is given by Q1 by Q2 is equal to N1 by N2. Okay, Q1 by Q2 is equal to N1 by N2. So now using this formula, just solve for Q2. Q2 is how much? Q1 into N2 by N1. This will be equal to okay, let me erase the part. Let me erase this given part. Q2 will be equal to how much? 300, isn't it? 300 what? Liter per minute. Okay, liter per minute. So N is how much here? 1000 into 300 into 1200. Okay, so here we're not changing still. This is equal to how much? 360, isn't it? Liter per minute. Now if you convert it into meter per second, if you convert it into meter per second, then what will it be? 360, uh, yeah, divided by 1000, isn't it? 1 liter equal to, 1000 liter equal to 1 meter cube. And per minute. So per minute is how much? In second, it will be 60. Okay. So after conversion, it will give you 0. Just tell me the answer. I will not tell you this answer. You tell me what after conversion, what will be the answer? Kindly write in the chat box. Tell me quickly, quickly. Let's see your engagement. चलो जो कोई भी बताएगा मुझे पहले कल आके मुझसे एक चॉकलेट ले जाओ, ठीक है? Just tell me, convert करो in meter per second, convert and tell me. I'm waiting. Okay, nobody wants to eat chocolate, it seems. So, okay, I'll just tell you the answer. This is equal to 0.0006 meter cube per second. Okay, आप लोग खुद ही सॉल्व कर लेना. Now, इसके बाद क्या करना है हमको? पावर. पावर का फॉर्मूला क्या है? Can anybody tell me? So after this, we have to calculate the power, okay? Because it's asking the power required for this new speed, isn't it? So power is always given by rho g h2 q2. This is, since this is for a new speed, so we have to use the second data, isn't it? So rho g h2 q2 divided by n. Okay, so this is equal to how much? Rho is how much? Density of water 1000 into gravity 9.81 into your the H2, this is equal to 43.54, and Q2 is how much? 0.006. Efficiency is 0.65. Okay, once you solve it, it will be equal to 3942.71 watt. So this is equal to how much? 3.94 kilowatt. Okay, so this is the answer. So everyone clear? This problem is clear to you all? Priyanka, Manish, Chitra. If you're present, kindly respond. Anisul, you're present. Okay. Manish, is it clear? Okay. 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 Lovely. Okay. So this is the final answer for power. Okay. All right. So I'm going to end my class here. And if you have any doubt, you can always reach out to me. Okay. So feel free to reach out to for any doubt related to your gate papers, especially in the soil water section and as well as the irrigation part. Okay. So if there is no questions, then I will end the class here and I will reschedule. I will schedule another class, and in the next class we will discuss we will try to complete all the questions. Okay, because since we are taking explaining the concept behind each and every topic, it's consuming more time, isn't it? So let's see, we may need to divide have two more classes to complete the whole questions from this SWCE and IDE part. Okay. So anyways, we will solve it by any means. All right then. Thank you all. Thank you for joining. You can leave the class now. Thank you very much. See you in the next class. Thank you, Chitra.